Tonight we're in for a real treat. It's so much fun to see some of our friends, new friends, and friends who have been with us for all of these. This is an amazing experience that we've had with Impact Hub, and thanks to UStar. Where's Ivy? Ivy Estabrook, thank you to UStar for making this happen, and for Impact Hub, Dustin, you did a kick-ass job in believing in this vision, creating it with us, and it's been a really fun ride so far. Tonight is a little bit different. We've been talking about technology changing the world in all different ways. And at our fire conferences, there are always people that come to me and say, my favorite person was, and it's always astounding, you can have Elon Musk there and talking about the next launch of the SpaceX. And somebody will come up to me and said, where can I find Khan Slobodchikoff? How can I reach the guy who communicates with animals? This is what we need to learn about. So we're very fortunate to have Khan with us tonight. So Khan, welcome.
Thank you, Sharon. I really appreciate that. Thank you all for coming.
Khan's been a speaker at our fire conference for many years. He has been featured in the Smithsonian Magazine, National Geographic, Discover Magazine. He's been on NPR's Wait, Don't Tell Me. And they got it wrong. The Prairie Dog question, right?
Right.
He has also been on all global interviews globally in the news. He was in New York Times last week. Now that you've met him and seen his name, you're going to follow him because he is the key to us relating to animals on the same wavelength. He stayed at our house last night, and we have 2 German Shepherds, and he told us all the things we were doing wrong. Our dogs have no problems, and we do, and we got straightened out in about 12 hours. So Khan, I think, in order to understand Khan and his amazing work that he'll tell you about how he's so passionate, so involved with languages between species and learning that other animals that we think are just like rolling around and just, bumping into a wall and changing direction actually have definitive linguistic skills among them. And we don't see that. Humans don't see that. And this is a very important thing for Khan. And I think that there's something that we all need to know before we start this with Khan, is that many people have tried to do documentaries about Khan. And Khan thought, I should make a documentary on the work that I've done to show that technology can communicate with animals, humans, together with each other. And he called me up and he told me, he said, I'm about to sign on the dotted line. They want $1 million. It's a UK company. I haven't heard from them. I'll fax you the proposal, and they'll produce it. And I looked at it, and they didn't even spell Prairie Dog correctly. And I said to Khan, we'll open our house for the weekend. And we brought in film directors, producers, Geraldine Dreyfus, our Fire Films ambassador, and really smart people that know about film and people that love animals. And by the end of the weekend, we did realize that the most fascinating part of this documentary is really Khan himself, which explains why he's doing what he's doing today, why we need to support him, to help him to continue our work. So the first question I'm going to be asking Khan is to tell us just a little bit about your growing up.
Well, my growing up has something to do with why I'm interested in animal languages. So let me tell you my story. I was born in Shanghai, China, of Russian parents. And so I grew up speaking Russian. That was the only language that I knew. And roughly at about the age of 5, my parents moved to the United States, and I was plopped down into school in the United States, in San Francisco. And I didn't speak a word of English. So at that time, teachers seemed to be unfamiliar with the concept that not everybody is born speaking English, that you don't have a gene for speaking English. And so they would get after me for not speaking anything. And so gradually I learned English, but what I would have to do is I would have to listen to what somebody said in English, translate it into Russian, figure out what my response was in Russian, and then translate it back into English. So I would hesitate when I spoke. The teachers decided that I had a speech disability. So they sent me to a very prominent child psychologist who said, yes, he has a speech disability. He stutters. So they sent me to classes where I learned how to take a deep breath when I couldn't come up with a word, snap my fingers when I couldn't come up with a word. And I tried to explain to them, I don't know the word. I can't come up with the word. I don't know it. But they said, no, prominent authority told us that you have a speech disorder. So that lasted for about a couple of years until my pediatrician, who was very well known in San Francisco circles, knew all of the school board, wrote a letter to the principal and said, I know that this guy doesn't stutter. I've heard him speak Russian. He doesn't stutter. Get him out of that program or I'll take it up with the school board personally. Next day, magically, I was out of those classes. But that taught me a very important lesson. It taught me that people who are experts can make wrong assumptions, and they can be wrong about what they do based on those assumptions. And that's really been the basis of my animal language work. So let me turn it over to Sharon.
So this totally answered my question about how he got into this. Khan has this gift of really communicating with animals without talking. I mean, I've seen him do it many, many times, and it's just there. And I think that is the way that he was raised, where he couldn't say what people wanted him to say. Gave him this gift to be able to communicate with others, not just animals, but with humans as well, in a really beautiful way. So let's start talking about the prairie dog. We have prairie dogs here. And Khan, for some reason, you chose the prairie dog to work with to try to understand language between prairie dogs.
Right. So at Northern Arizona University, part of my contract said that I was responsible for teaching, and part of my contract said that I was responsible for doing research. And at that time, there were around 50 colonies of prairie dogs around Flagstaff. So I thought, well, we don't really know very much about the social behavior of prairie dogs, and I've been interested in social behavior for a long time. So why didn't I study social behavior of these prairie dogs? They live in circumscribed towns. They're easy to get to. I don't have to load up my gear and travel 2,000 miles to some exotic place to study some animals. I can be right next door. So I started studying prairie dogs and found that they had alarm calls. And at that time, everybody thought that the alarm calls were just simple expressions of fear. Like, you see a snake and you say, ah! Or you see a coyote, you say, ah! You see a human, you say, ah! And it's all the same. So I started recording this, and at that time, a paper came out that some ground squirrels in California had two types of alarm calls. One for aerial predators like hawks and eagles, one for terrestrial predators like coyotes. And I thought, whoa, this would be cool. Maybe prairie dogs have that. Started recording that. Sure enough, I could sort them out into aerial predators and terrestrial predators. But it wasn't that clear cut. There was a lot of variation in there. Greater variation than you'd find through the individual variation of the voices. So then I had an insight. What if the prairie dogs are talking about the species of predator? Now, mind you, nobody believed this at the time. But I thought, what if? Here we go back to my idea of experts making assumptions. Experts made an assumption that these are all the same and only fear. And I thought, what if they're wrong? So I started setting up experiments and found, sure enough, they did have different words for different predators. One for coyote, one for human, one for hawk, one for a domestic dog. But again, wasn't really completely clear-cut. So again, I had an insight. What if they are describing the individual features of predators? Now, this was really way out at the time. Nobody believed that. Nobody hardly believes that at all today, even though I've published more than 30 papers about this in peer-reviewed scientific journals. But it turned out to be true, that prairie dogs do indeed describe the physical features. They can tell how tall you are, what your general shape is, what color of clothes you're wearing, your speed of travel. Same thing with the coat color of dogs and coyotes, their general shape. So it's a remarkably sophisticated language. And we found subsequently doing experiments that they can identify, they can make up new words, for example, for ovals that we run across the colony on a string. Now I can assure you there are no ovals running around in prairie dog colonies trying to prey on prairie dogs. But they made up a word for it, all the same. We had another experiment where we showed them circles and triangles. They all made up the same word for circle and a different word for triangle. So they can make up new words even though they've never seen these things. Just the way that we make up new words like cell phone or Xeroxing, all these kinds of things that enter our vocabulary.
It's really cool if you guys get a chance to Google Khan. First of all, you should definitely buy the book, The Real Dr. Dolittle. But what Khan has seen and analyzed and seen that's happened with these prairie dogs was just enough to get him excited to keep on going on to more and to really think about what is communication and what is language. And so what I want to ask you is, first of all, what is the difference between language and communication, and why do you think it's important for us to respect and learn that animals do have their own languages?
So biologists, linguists, and philosophers for a long time have said, we humans are the only ones with language. All the other animals, all they can do is communicate. So let me tell you the difference between that. Communication, as biologists refer to it, is just a simple stimulus response kind of thing. A signal comes in, and the animal is programmed by instinct to respond with a specific signal to that. The animal can't make any decisions. The animal has no flexibility in the response. It's always the same response to a particular signal. So this is what biologists and others believed, and many people still believe that. And this sets up a gap between us and the rest of the animals, because we're the only ones with language, according to this idea, and all the rest of the animals, poor animals, all they can do is communicate. So language, on the other hand, involves several things. It involves flexibility, that the animal can make a decision as to what signal to send. It involves intentionality. The animal intends to send information to other animals. It involves novelty, being able to make up new signals. And it involves some kind of structure, which we in our languages call grammar, or we might call it syntax. So the idea was that there was this gap separating us. And I think why it's important that we recognize that a lot of animals have language is that that gap keeps us separate from all the rest of the animals. It keeps us from empathizing with all the other animals. A lot of us tend to see animals as kind of little robots running around on programs of instinct, not really aware of what they're doing. And if we can get rid of that gap, then we can make people empathize or let people empathize more with different animals. And maybe this is a good time to show the prairie dog video.
Absolutely.
So we're going to show you a short video that summarizes a lot of the experimental work that I've done. This is all work that has been published in the scientific literature, so it's not something that I'm pulling out of thin air. It's actually out there in print. So let's take a look at the video. Hello, my name is Slobodchikoff. I would like to tell you about the studies that my students and I have been doing in decoding the language of prairie dogs. Our studies have concentrated primarily on the language of one of the 5 species of prairie dogs, the Gunnison's prairie dog. However, It is very likely that the other 4 species of prairie dogs also have similar complexity in language. Prairie dogs have alarm calls that they give when they see a predator. These alarm calls are a series of relatively high-pitched notes that sound somewhat like a bird chirping. The alarm calls have been a Rosetta Stone for us in decoding prairie dog language because we can see the predator approach, we can record the alarm calls of the prairie dogs in response to the predator, we can videotape the escape responses of the prairie dogs, and then, when there is no predator present, we can play back the alarm calls that we previously recorded and videotape the escape responses of the prairie dogs to the playback. If the escape responses to the playback match those that happened when the predator was present, then we know that there is meaningful information encoded into the alarm call. We can bring the alarm call recordings into our laboratory and use computer analysis to look at the acoustic structure of the calls. Computer software generates a sonogram, which is a pictorial representation of the frequencies and time values contained in a vocalization. Prairie dog alarm calls look like a series of stacked chevrons, kind of like sergeant stripes with the peak pointing upward. Each call is about 1/10 of a second, so it is very brief. Most of the calls are repeated multiple times, so that you hear something that sounds like. We can then measure the frequency and time values within a chirp and use statistical analysis to determine whether an alarm call for, say, a coyote is the same as or different than an alarm call for, say, a human. So the analysis of the sounds is based on rigorous statistical methods. Using observations and experiments, we have found that prairie dogs give different alarm calls to different species of predators. They have one alarm call that they give for coyotes that sounds like this. They have another alarm call that they give for domestic dogs that sounds like this. They have a third alarm call that they give for humans that sounds like this. They also have a single note alarm call that they give for red-tailed hawks that sounds like this. Amazingly enough, even though some dogs look like coyotes, prairie dogs never mistake a dog for a coyote or vice versa, and always give an appropriate alarm call for each. We have also found that each alarm call contains information not only about the species of predator, but also contains information about the description of the individual predator. For example, a human alarm call contains information not only about the intruder being a human, but also contains information about the size, shape, and color of clothes that the human is wearing. When we do an experiment where the same person walks out into a prairie dog colony wearing different colored t-shirts at different times, the prairie dogs will have alarm calls that contain the same description of the person's size and shape, but will vary in their description of the color. Like many mammals, prairie dogs have dichromatic vision, which means that they can see blue, some green, and yellow, but not red. Using experiments in the field in the laboratory, we have found that prairie dogs can also describe the size, shape, and coat color of domestic dogs. Amazingly enough, prairie dogs can also describe objects that they have never seen before. In one experiment, we showed prairie dogs a silhouette of a black oval, and they all consistently had the same alarm call for the black oval. In other experiments, we have shown prairie dogs silhouettes of circles and triangles, and they consistently have different alarm calls for the circles versus the triangles. Using computer analysis, we have shown that the alarm calls are made up of smaller units of sound, very much like human phonemes such as vowels and consonants. So each alarm call of a prairie dog is equivalent to a human sentence composed of nouns and adjectives, and smaller units of sounds that make up these nouns and adjectives. The nouns are the species of predator, such as coyote or domestic dog. The adjectives are the physical descriptions of the predators, such as tall, thin,
or yellow. We have also found that prairie dog alarm calls have dialects, much like human dialects. Just like a person from California might say the word dog somewhat differently from a person saying dog in Georgia, prairie dogs also have slight differences in the way that they pronounce an alarm call for, say, human in Arizona versus in New Mexico versus in Colorado. Prairie dogs have other vocalizations that we can't yet decode because we don't know the context. They have social chatters in which one prairie dog will lift up its head and go chatter, 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 and another prairie dog somewhere in the colony will respond with another string of chatter. Nothing about the behavior of the two prairie dogs changes. We can show that the syllables within the chatters are different, but because there are no behavioral changes, we lack the Rosetta Stone to decode the meaning of this. Prairie dogs also wave their tails around in a behavior known as tail flagging. But again, we don't know what the meaning of this is either. One of the best known signals of the blacktail and Mexican prairie dogs is the jump yip, where the prairie dog stands up on its hind legs, stretches its front legs up towards the sky, and produces a yipping call. This occurs in many different contexts, such as territorial disputes, a predator leaving, or a snake appearing. No one has looked at the acoustic properties of these calls to see if they're different for different contexts. Sometimes the jump yip call occurs when there's no obvious context. Maybe in that case, the prairie dogs are simply saying, "Hooray, it's a wonderful day." I am often asked whether prairie dogs of one species can understand the language of prairie dogs of a different species. While I have not done the experiments to test this, just looking at sonograms of the different species vocalizing to the same human wearing the same color of clothes suggests that the answer is probably no. It looks like the different species have different languages, just like we have French, Spanish, German, Russian, and Portuguese. At the present time, prairie dogs have the most sophisticated animal language that has been decoded, more sophisticated than even primates, whales, and dolphins.
So that's a summary of the experiments that my students and I have been doing over a number of years. It takes a long time because each experiment takes one summer to set up and run. So it's been a long time gathering this information. But you can see how complex and sophisticated this animal language is.
It's interesting because after I saw this from Con, I think 2 years ago, I saw a notice in my inbox about it's hunting day for prairie dogs in Iowa. Whoever kills the most, gets some sort of prize and a T-shirt. And I thought, if these people saw what these animals are talking about and could relate to them as beings, I don't think a lot of people would immediately jump to trying to kill the prairie dogs. I think the same thing in our neighborhood. People are complaining because, there's these, tunnels. But if they knew that the prairie dogs talk to each other, they laugh together, they play games together, they enjoy the day, they know how to say different animal names, and they're not going to harm anybody. They just want to be in their own environment and enjoy the territory. I wouldn't mind having a few holes in my yard, and I'm not going to put a gun down one of those holes to ruin a community of prairie dogs, and that's just one here. So, Con, talking about, we talked a little bit about what other kind of animals have you noticed, looked at that you can describe some of the things they do, and then we'll go on to talk about dog.
Okay, so one of the things that I started getting interested in after all of this prairie dog work was to look at how much information do we have about other animals in terms of language. And I started looking through the scientific literature, and I found that we have an amazing amount of information about other animals having language. It's just not called language in the scientific literature because language is still considered a no-no. You can't get things published if you talk about language. You can get things published if you talk about language-like things and call it communication. So I wrote a book called Chasing Dr. Dolittle, which you can find on Amazon if you want, and there's a lot of examples in there. For example, one of the things that we know is that lizards have grammar. They can do various kinds of signals like head push-ups, they can lift an arm, they can lift another arm, they can lift two arms, but I can't do that with the microphone here. They can lift their tail, lift their back legs. It's all done in a grammatical sequence, which means different things. Some of it means, I want to mate. Some of it means, you're on my territory. I'm feeling aggressive. I'm feeling not very happy with myself, and so on and so on. Bees and ants, for example, have very sophisticated chemical languages where they have a variety of chemicals, and they can change the concentration of each of those chemicals. And changing the concentration is like changing words in a sentence. So they can provide a lot of information to other bees and other ants just by changing those chemicals. And we never think of it because we're not really very good at sensing things through our nose. So there's a lot of animals which, it turns out, have either language or language-like abilities.
You're working on technology now to talk between humans and dogs to understand and decode the language. Okay, can you talk about that a little bit and then show
Sure.
the video?
When I was working with prairie dogs, a computer scientist and I worked out a scheme where we were using artificial intelligence technology to record the prairie dog vocalizations, use the AI technology, and the computer could tell us, hands off, no statistical analysis on our part, what that call was all about. And potentially we could go back and say to the computer, generate a call for a coyote, and the computer could generate a call for a coyote using artificial intelligence technology. So I wanted to transfer that sort of concept to coming up with a translation device for dogs so that we would be able to understand what dogs were saying and that we could get dogs to understand what we're saying. And the reason I want to do this is, first of all, we currently euthanize between 2 and 4 million dogs a year, mostly for behavioral problems from kill shelters. And a lot of those behavioral problems could be solved if we could communicate with dogs and essentially find out what is it that they need from us, or tell them what is it that we want to convey to them. And so right now I'm working on trying to come up with a way to build this kind of translation device, which would involve both optical information in the form of body language and acoustic information in the form of vocalizations. And we know that dog body language is very rich. And if we could take a look at the next video, you'll see something about dog body language. Slobodchikoff. I would like to tell you about dog body language. We now know that about 70% of dog language is through body language. Let me tell you about the principal signals that are important in this language. Body position is a very important signal. The higher the dog's body is positioned, the more dominant the dog appears. A lower body position implies that the dog is more submissive. Several features around the head are important. As with body position, the position of the head is an important signal. The higher the head is held, the more dominant a dog appears, while a lower head means that the dog is more submissive. The shape of the eyes is an important signal. Eyes that are narrow means that the dog is feeling aggressive, while eyes that are wide open means that the dog is feeling calm. The ears provide important information. When the ears are up and pointed forward, the dog is confident. If the ears are pointed toward the back or lying down against the head, the dog is not very confident and frightened. The shape of the mouth when the dog is snarling and baring his teeth is a very important signal. If the mouth is puckered so that only half of the mouth is open and the teeth are bared, the dog is feeling angry and aggressive. If the mouth is open all the way while the teeth are bared, that means that the dog is feeling frightened. Either dog can bite, but for different reasons, one through anger, the other through fear. Another important signal is the tail. When the tail is held high, the dog is confident. When the tail is held low, the dog lacks confidence and may be frightened. Just because a dog is wagging her tail is not an indication that she won't bite. An aggressive dog will hold her tail up and will wag the tail slowly. And a happy dog will wag her tail more to the right than to the left. Dogs have some signals that are called calming signals, which are given when a dog is uncertain and wants to diffuse the tension of a particular situation. These include looking away from another dog, licking the nose, and sitting down and yawning. When dogs want to play or want to diffuse a tense situation, they will often do a play bow, which involves lowering the front of the body and keeping the rump and tail high. Smiling and laughing are two other signals that dogs have. Smiling involves opening up the mouth completely without baring the front teeth and letting the tongue loll out. Laughing involves opening up the mouth and breathing air in and out very rapidly. All of these positions are combined together like different parts of a sentence, and each body part can be varied through different positions, which is like changing the words in a sentence. Think of how many ways a tail can be held from straight up to straight down. The bottom line is that dogs have a rich language, and we are just on the cusp of decoding it. Soon we will be able to understand what dogs are saying when they talk to each other and to us. So comparable to that, we're also finding out that dogs have a very rich acoustic language in their whines, their barks, their inflections, and so on. All of those have meaning. So it's perfectly feasible at this point to start developing a device that would allow us to talk to dogs and to save our dogs. I mean, who wouldn't like to know what their dog is thinking? How many of you would like to know how your dog is thinking? Raise your hands. Okay, how many of you would not like to know what your dog is thinking? I see one hand tentatively raised.
But here's one. How many of you think that you know what your dog is thinking? Okay, right, okay, what? He'd come to your house and he would prove you wrong.
Yeah, in most cases, people are remarkably good at misinterpreting what their dog is thinking. They have a remarkable capacity for that. I don't know what it is.
And here's the thing, we're talking about dogs and all beings. If we can understand more, you know, we're humans, top of everything, smartest, own, blah, blah, blah. If we can understand and relate to, we are great, many of us, almost all of us have compassion. And if we know that there are other beings have feelings, compassion, have families, have social lives, you know, interact with each other, enjoy life, I think that we as humans would change our behavior. Khan is an amazing man. He's been working on the prairie dogs. There's so much more to that. You really need to get the book about Dr. Dolittle. But the now bringing this into the dog world, where we have so many euthanasias, Best Friends, Utah, I'm so proud of that place. You know, they do such a great job. But with the technology that Khan has, that he knows how to make, that he knows what he needs to do with it to get that to happen, placement of these dogs would be so much easier, because there would be a language, no barrier, of what can I give you, what can you give me, and what do we need together. And I have tremendous respect for Khan. And for the rest of the people, there are experts working on whale communication, dolphin communication, you know, upper species, bonobos, gorillas, chimpanzees, elephants. You know, elephants hear through their feet, yet we put them in cement floored zoos. There's so much that we don't know. And it's not that we're cruel. I see a wave now coming through of people really working on connecting with animals, especially of intellect. But those that are not even animals of what we call of intellect are still often smarter than we are. For example, the African termites?
I'm
The
sorry.
termites?
The termites, yes. Right. The termites in Africa build mounds that go up 7 to 10 feet tall. And when you put that into perspective, that a termite is about half an inch to an inch long, that mound is the equivalent of maybe one of our skyscrapers that goes up 3 miles. Do we have any skyscrapers that go up 3 miles? We don't. But the termites do by comparison. And they have a rich language in terms of chemical communication. And let me tell you, in terms of other animals, there's now groups of people who are working to try to decode the language of dolphins, because we all know that dolphins make a tremendous amount of vocalizations, and we all intuitively assume that dolphins have a language. And there's a Swedish company right now which is trying to figure out how to apply artificial technology, artificial intelligence technology to analyzing dolphin sounds. And there's a group in Florida and Georgia Tech who are also doing similar kinds of things. But the problem with dolphins is, if you look at one of these spectrograms that I showed you with prairie dogs, dolphins are constantly chattering. And one of these spectrograms looks like just a bunch of spaghetti across the screen. And you try to figure out what any of that means. What are the parts in there? Where are the words? Where are the parts of words? It's really hard. On top of which, dolphins use different postures. They stand heads down in the water. They stand with their tails down, their heads up. They change their posture. And all of this happens underwater. So it's a really difficult problem with dolphins. But the dogs, we live with dogs. They're all around us. We're familiar with dogs. And here's the best thing, that a lot of dogs understand our language. We're not very good at it with their language, but a lot of dogs understand their language. There's a dog called Chaser, which knows upwards of 1,000 words in English. There's a dog called Rico, which knows upwards of 300 words in German. So we already have a start with the dogs being able to understand us to some extent. We just have to be better at understanding them.
So, hats off to Con for all of your hard work that you've done with the prairie dogs. And we at Strategic News Service want to do something special. We want to help you support this work. We want the technology to be made so that we can communicate with the dogs. We want our people to be behind you. So on behalf of Strategic News Service, I'm honored to tell you that we will start the Kickstarter campaign for you, pay all of the fees.
Wow.
And we're going to put your name up here at the end of the session, but you don't have to put out anything. We're going to support you with our connections as well for companies that have global organized databases, which is really what is needed besides the devices with technology, right?
Right.
I think you were talking about, well, also you need to give 20 to 40 dog sitting agents,
Doggy daycare centers. Right.
The microphones, videos, and you're going to need help and money with that, to do that, to be able to collect the data so that we can put that in a global database, and we can do just like what you did with the prairie dogs, and we can really actually communicate with these animals. And I'm very excited to say that you don't have to worry about it. We're going to start the Kickstarter campaign for Con right now for the work on dog. So this will be a day that hopefully you'll remember, when you will be able to communicate with any dog that you see.
Well, thank you, Sharon. I'm stunned and I'm very appreciative. And if it weren't totally undignified and physically impossible and I were on film, I would wag my tail and prick up my ears.
I told him to do it. I asked him if he would just do it.
No, it's totally undignified. If it gets out among my colleagues, that'll be the end of it.
So we'll open this up for Q&A now. We usually do 12 minutes of Q&A at the end. Who has a back there? Orange, you.
Yes,
no,
you.
it's you. Stand up. Pretty woman, wearing orange. Coral.
Actually, if you could come here. That
Okay,
would be
yeah.
great. They're just recording, and it'd be great to have the sound.
Hello. Very interesting lecture. Amazing.
Thank you.
Two questions. One about the phonetics. Did you notice in your work any of the animals, do they only use vocal cords, or any of them use the actual tongue already to produce the sounds?
Well, different animals use different techniques for producing the sound. Some of them use their vocal cords, some of them use the mouth cavity, some of them use the nasal cavity.
But any of them use the tongue?
I don't know. I don't have an answer for that one.
Just would be interesting from the intelligence standpoint. That's what I think defines the human language, is that the various tongue positions that
What
we're
about
using
the
to
clicking
produce
in
the
the
sounds.
dolphins?
Yeah.
You know, whales and dolphins click. Right? They click and
Right.
click like-
I don't know. Do they click with the tongue or with the nose?
Yes, they do click with their tongue. And I'm sorry, I didn't actually hear your question. I didn't realize that you were talking about the tongue.
The tongue, yes. I'm because for me it's interesting when we're talking about the level of intelligence. I'm thinking that the use of tongue is something that distinguishes us humans from animals, right? And I'm just wondering whether any of them moved up that chain of intelligence and started using their tongue to produce the language sounds.
Well, actually, once again, there are animals. Dolphins, for example, will use their tongues. Elephants, to a certain extent, will use their tongues. There's a bunch of animals will use their tongues. But my position is that it's not use of tongue that defines language, and it's not use of tongue that defines human language versus animal languages. It's the way that the signals are structured and the information that's contained and the intentionality in it. So, for example, humans have a vocal tract that is kind of hook-shaped, which allows us to articulate the words that we use. And people tried to teach chimps to speak. There was an experiment where a chimp was people attempted to teach the chimp to say mama, papa, and cup. And it was very painful because the chimp had to learn to cover his nose and say, blah, blah, and everything sounded sort of the same. And it turns out that chimps don't have that hooked vocal tract, and so they can't articulate the signals. But chimps have an extensive vocabulary of hand signals, which they give. And that was the basis for some of the work, like with a chimp like Washoe, where they taught American Sign Language, which, by the way, linguists until only very recently conceded that American Sign Language was a real language. Previously to that, they debated hotly the question whether American Sign Language was a real language. So there again, experts can be wrong. So, you know, the point is that different species do things differently, but the idea is that they all produce information that fits the criteria of language.
Then the next question will be, to build on that, have you ever, you or any of the people who've done work in this field, look at the structure of the language? When you were talking about prairie dogs, you kind of, the way, you know, at least I read it, it was when they communicate, they say, okay, this is a human, this is the adjective. So it seems like very simple, like word, 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 right?
Right.
Any of them have any interesting structure?
Well, this is something that I'm working with a linguist right now, and we are dissecting out the linguistic properties of this and showing that there is indeed structural grammar involved in how all of this is put together. You know, and the fact that they have phonemes, you know, was really amazing to me, quite frankly, because they use the same phonemes for hawk and coyote and dog and human, but they were rearranged differently, you know, just like phonemes in a human language are arranged. So we're working on that right now. And it's obviously a slow process, you know, because science progresses slowly, unfortunately.
But do you think, in your mind, would that be significant of a level of intelligence of the animal?
In humans?
No, not in humans. We can compare it to the human. In my mind, some of the ancient languages, Sanskrit, Latin, show that they're more advanced, and I think showed that humans were very intelligent. So I wonder if the same parallel you would, as a scientist, make the same conclusion that if the language structure of one animal is more sophisticated than of the other, would that signify the level of intelligence of that animal?
I have a more ecological viewpoint of this, in the sense that I think that the languages of animals are specifically designed for their ecological circumstances, the world that they live in. I don't know if Sumerians or Babylonians or Hittites had a more complex environment that they lived in than what we live in today. Certainly Egyptians built very complex pyramids that were based on very complex mathematical principles, and Babylonians had all kinds of knowledge of stars and so on. But as to whether the complexity of language goes along with intelligence, I really couldn't answer except in an ecological context.
Okay. All right. Well, thank you so much.
You're welcome.
Any other questions?
Yes.
Amy.
I was wondering about the process for you for deciding to take this work on, to be the translator.
I'm sorry, could you?
Sure. To be the translator for the animals, what it took for you to take this work on. If you considered not doing it, if you felt like maybe it would hurt your career because of how we think of animals, that it is almost soft-headed to think that animals are intelligent. Like if there was a moment in your career where you decided, okay, I'm going to do this, or if it was just a natural evolution.
I think it was a natural evolution, but on the other hand, I would never have taken this on if I didn't have tenure. Because unfortunately, even now, it is considered sort of bad form to talk about animals in the context of language. And I once did a study looking at the web of science. In the last 100 years, there was something like 300,000 papers that talked about animal communication. And in the last 100 years, there were 107 papers that talked about animal language. So, if you don't have tenure, you got to go with what is accepted.
It seems like this is much more of an ongoing, successful research subject for many people. Has anybody seen Unlocking the Cage? Okay, if you haven't, then you should. Go to firefilms.net and we'll share this with you. Unlocking the Cage, we showed it as our Fire featured film at Fire last year. We brought in Steve Wise, the subject of the film. Stephen Wise is an attorney who is whose clients are animals of intellect, chimpanzees, bonobos, elephants, whales, dolphins. And what he does is he's an attorney, and he has a whole bunch of volunteer attorneys. They go to court representing animals that are in abuse situations that are of intellect. And right now he's about to free 2 monkeys who can communicate very well together with us and with each other to a sanctuary. It's always important to have a sanctuary to be able to put the animals in after you win the case. So this is a huge thing that's going on right now. It's a global initiative. And if I would look up Stephen Wise or join firefilms.net, and you'll see what's happening now, where we're respecting these animals of intellect. We're understanding now what they're saying. They're understanding what we're saying. And we're trying to live together, cohabitate instead of rule. So any questions before we go? Go ahead.
So you said in the beginning when you were talking about your early life that your teachers thought that there was like a gene for English. And so I was wondering if you took like a prairie dog from a wild colony and kept it in captivity as it was growing up and then placed it back in the wild, would it be able to communicate with its colony?
Well, we did one experiment where we recorded black-tailed prairie dogs, which live in New Mexico. We recorded their vocalizations for badgers and for coyotes. And they had distinct calls for badgers versus distinct calls for coyotes. Then we went to the New Mexico Zoo and recorded the vocalizations of the black-tailed prairie dogs that were living there, that had lived there for at least 9 generations without any new prairie dogs coming in. And what happened was that those prairie dogs had sort of a generic call. They had sort of the yip, 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 but there was no structure to it. There was nothing that would tell that it was a badger, nothing that would tell that it was a coyote. So apparently, through learning, they acquire this. And actually, it's fascinating to me that we have witnessed upon occasion prairie dog schools where moms teach baby prairie dogs how to vocalize for the appropriate things. And what happens is that mom stands up there and let's say she gives a coyote call. There's no coyote out there. She just gives a call, chip, 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 chip for a coyote. And there's maybe about 6 or 7 young out there, standing up on their hind legs going, blah, 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 blah. And mom patiently goes, cheep, 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 cheep. And they go, blah, 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 blah. And gradually over time, they get better at it and they learn what a coyote call is. And then when they actually see a coyote and they hear mom doing the coyote call, they associate, oh, that's what mom was trying to teach us. So it's a learned kind of language in part. And obviously there is a genetic component in making the generic sort of sound, the generic chevron type of sound. But then how that structure is imposed is a learned component. And I was actually facetious about my teachers thinking that there was a gene for English. I'm sure that they didn't.
That was a great question, by the way.
Thank you.
Okay.
So there's been lots of animals that we've been able to teach like English language to, like crows, ravens, parrots, things like that are like have a high intelligence that can actually recognize those words, and they don't just mimic, they can actually recognize it and say the word itself. Did you choose prairie dogs just because of the accessibility in the community that they live in, so it was easier to like see them communicate with each other, or is it like, why wouldn't you choose something that we've already recognized that in them and that they can actually speak the language, that we would possibly be able to translate actually English language and Raven or whatever like that?
Well, I chose prairie dogs for really 2 reasons. One is, as you suggest, the availability of the animals. They were right practically outside my university door. Not exactly, they were a mile away. One of the colonies was a mile away in an undeveloped area of Flagstaff. So they were easily accessible. But the other reason why I chose them is that in all of the stuff that I did, I used statistical analysis. And for statistical analysis, you need large sample sizes. You can't do statistics on 1 or 2 animals. You know, this has been the criticism of a lot of work where people have taught animals English or sign language or something like that, that the sample size is 1 or 2 or at best 3. And so people can say, critics can say, okay, well, these were geniuses of the animal world, but really, other parrots can't do this kind of thing. It just happened that you're working with the Einstein of parrots. So I was trying to come up with a large sample size. And when you have a colony of 100 to 150 prairie dogs, you instantly have a sample size that you can use for these kinds of fairly sophisticated statistical analysis that I needed to do to show that really there was information in there. So it was a combination of both.
So we're going to close this, but before we close this, I want to say, can we put Khan's email address up on our screen? We did it. Please, if you would like to be involved in helping Khan to create the technology to communicate with dogs. Really important project. We will be talking about this at our fire conference for every year from now on. Please look for the Kickstarter campaign. Write to Con, say, I want to be involved in the Kickstarter. He needs, even if you can donate time, he needs some help with this. And we're totally behind him and we're really proud to be behind him. We also have a very special code. If anybody wants to go to the Future in Review conference, which you saw the 3-minute trailer for, this is our 3rd year in Utah, which is awesome, and it's our 15th year total. The Economist calls it the best technology conference in the world. We're giving Utah residents and friends $1,500 off the registration fee with a special code. If you can't find me, it's very easy to remember. It is Fire Utah 2017. So with that, let's give Con a hand for all the hard work he's done for people.
And thank you all for listening. And I hope you have a new perspective on prairie dogs and maybe other animals as well. My goal is to eventually get us to the point where we see other animals as partners in the natural world rather than robots or vermin or pests or disposables. I'd like to see a world where we're all in harmony together.
Amen.